In this video, we will look at section 1.2, the fundamental operations of algebra. And so we want to look at some laws that can be followed when our literal numbers, which are the letters representing real numbers, are used. And so the important thing to keep in mind is that the letters that we are using, which we are calling literal numbers, in this case, they represent real numbers, okay? Any real numbers. And so the first fundamental law of algebra that we will take a look at is the commutative law of addition. So what this tells us is that we can add numbers in any order and we still get the same result. So the literal form of the equation tells us that a plus b is equal to b plus a. And that should make sense if you think about adding two real numbers, like 5 plus 3 equals 3 plus 5. It doesn't matter what order we add them in, they will still give the same result. It also works for algebraic expressions, and so we'll give an algebraic example for each of these laws as well. And that 2x plus 4x squared is equal to 4x squared plus 2x. There is also the associative law of addition. Associative means that it doesn't matter what order we perform the operations in. We can use different groupings and we still get the same result. So the literal form of the equation looks like a plus bracket b plus c end bracket is equal to bracket a plus b end bracket plus c. So you'll notice the brackets tell us about grouping. First, on the left side, we would find the sum of b plus c first and add that sum to a. Whereas on the right side, we would find the sum of a plus b first and add c to that sum. And so the grouping doesn't matter. And if you look at the example with numbers, 3 plus 5 plus 6 equals 3 plus 5 plus 6. The order that you do the addition in does not matter. Same with the algebraic expression. Negative 1 plus, and then in brackets, 2x plus 4x squared is equal to, in brackets, negative 1 plus 2x, that full sum plus 4x squared. There is also a commutative law of multiplication, meaning that in its literal form, it looks like a times b is equal to b times a. And numerical examples, if we look at them, 3 times negative 2 is equal to negative 2 times 3. The order does not matter. We can multiply numbers in either order. Even when we are multiplying a whole number by a rational number, as in the second numerical example. The same applies to algebraic examples, because our literal numbers x and y would represent real numbers. So 2x cubed times y is equal to y times 2x cubed. And this is very helpful when you are simplifying algebraic expressions to know that it doesn't matter what order you write them in, because generally we would write an algebraic expression of this product with the numerical coefficient first and then the literal numbers in alphabetical order for simplicity. All right, so this law is helpful for doing that. There is also the associative law of multiplication. So associative means that we can group the factors in any order and we will still get the same result. So look at the literal form. A multiplied by the product of b times c is equal to a times b, that product multiplied by c. So if you need to rearrange the factors of your product, it's fine because the result will still be the same. In the numerical example, we'll see that negative 2 multiplied by 3 times 5, and the brackets would tell us we should find the product of 3 times 5 first, and then multiply that result by negative 2. Whereas on the other side, we could do negative 2 times 3, and that product would be multiplied by 5. Sometimes this law is very helpful when you're trying to find products in your head. So you don't have to necessarily use the order that's given. You can use an order that makes it easier for you to multiply in your head. The algebraic example, in brackets you see 2y times 4z. That product would be found first, multiplied by 3x. Or we could also do the other order, 3x times 2y times 4z. So all of these examples illustrate the associative law of multiplication. Now the last law that's very important for us to take a look at is the distributive law. The literal form of the distributive law tells us that A multiplied by bracket B plus C. And notice this is different from above because in the above one we had a multiplication in this location. If in the brackets we have a sum or a difference, which means addition or subtraction, with a product out front, then that means that A should be multiplied by each term inside the brackets. It's multiplied by B and it's multiplied by C. And so you will see that when we split that up, we get A times B plus A times C. And this is one that I find is commonly forgotten about. So we'll see some examples at a later date to show you why the distributive law is very important. Now, a numerical example, if we were to find the sum of 4 plus 2, which is 6, and multiply it by 5, we get 30. Or if we use the distributive law, 5 times 4 is 20, plus 5 times 2, which is 10. 20 plus 10 is 30. Now, the distributive law is not needed in this case because it's all numerical. But we do need the distributive law when we have literal numbers involved where we cannot find the sum inside the brackets. For example, this algebraic example down here, I can't figure out what 2x plus 4 is at this point because these are not like terms, so they cannot be added. So we would need the distributive law, 3x times 2x plus 3x times 4. And just in case you're the kind of person that really likes these things finished, let's finish this up. 3x times 2x is 3 times 2, which is 6. X times x is x squared. And 3x times 4 is 12x. All right, we'll get working on that later on in the chapter, but I just finished that because I know some people like to see things finished up. This is really just an illustration of the distributive law. In the next section of this area of study, we are looking at operations on positive and negative numbers. So we will first take a look at addition and subtraction. We are going to look at adding a positive to any number. So for example, we might see, let's go and see 5 plus, I'm going to say positive 2. All right, I'm just saying a positive because later it's going to be a negative. So normally we don't have to write this, but this is really just to exaggerate the fact that we are adding a positive number. So 5 plus positive 2, that's something you've been doing for an awfully long time. This value increases in size and this becomes 7, right? Even from the negative, if I was to say negative 4 plus positive 8. Well, starting at negative 4, if I add positive 8, think about temperature. If you get confused when we throw in the negative. If the temperature is negative 4 and it goes up 8 degrees, then it goes past 0 up into the positive and it becomes 4, positive 4. Okay? Now, that's pretty common. You've been doing that a long time. Subtracting a positive, if I have 6 subtract positive 2. That's just 6 subtract 2. That's 4. Even from the negative side, if I have negative 8, subtract positive 1. So if the temperature is negative 8 and it goes down 1, right, gets lower, it becomes negative 9. So if you notice, when we subtract a positive, our number decreases. When we add a positive, our number increases. That's a generality that we can just keep in mind, okay? Now we're going to switch things around and look at adding a negative. If I say 5 plus negative 2, well, when I added a positive, the number increased. So when I add a negative, the number will decrease. It will decrease by 2. So this goes down to 3. And one of the things that's very helpful to remember is we can change the operation to negative. We can change the sign as well to positive. So we are essentially doing what we did over here. 5 subtract 2. Okay? Now, for subtracting a negative, let's see. 6 subtract negative 2. Well, when we subtract a negative, the result is going to increase. So we'll go from 6 and we'll increase by 2. This should become 8, but let's see how we can work that out a little more easily. We can do the same. Change the operation and change the sign of the number. So now we are adding a positive, much like this. Okay, so for these two down here, if it's helpful for you, change operation and you must do both, change sign. Okay? So if you get confused by working with signed numbers, then this is important for you to practice the sections on this. Next, we'll take a look at multiplication and division with signed numbers. So when we do a multiplication of numbers with the same signs, so say we are multiplying positive 3 by positive 4. When the numbers have the same sign, the result is positive. And the same will happen with negatives. These are the same sign, so the answer is positive. Okay. With division, the rule is the same for division with same signs. So let's see. Whoops. 20, positive 20 divided by positive 5. And that is division with the same signs. It should be positive 4. The same with negative 20 divided by negative 5. Negative divided by a negative, they cancel each other out, become positive. For multiplication with opposite signs, then the result will be a negative. So let's try negative 2 times 4, positive 4. The answer is, because we are doing a negative times a positive, a negative 8. And division with opposite signs, positive 30 divided by negative 2. It is positive divided by negative, so it's negative. 30 divided by 2 is 15. Next, we'll take a look at order of operations. When there are multiple operations, you must follow the correct order of operations. So the first step is to evaluate any bracketed values or parentheses. So any operations included in brackets should be done first. We summarize this with a B, or for some people, if they've learned it, possibly a P because of parentheses or brackets. The second step is to evaluate any operators. Operators include exponents, roots, and radicals. And a lot of people just remember this as exponents, but that's because roots and radicals can be expressed as exponents. So the E really summarizes all of that, actually. But if you want to use the letter O for operators or E for exponents, either one is fine, as long as you remember what it includes. Next, we will see that the third step is to perform any division or multiplication from left to right. And that is D and M in our acronym. And lastly, addition and subtraction can be done from left to right. Addition and subtraction. So some common words to help us remember order of operations. BODMAS, if you're using B for brackets, O for operator, or BEDMAS, B for brackets, E for exponents. Some people use, instead of B for brackets, they say parentheses, so it could be PODMAS or PEDMAS. And I'm sure if I have missed any, that you may have learned a different abbreviation, and if it works for you, keep using it. Here are some examples of order of operations, and now I'm going to give you a chance. If you would like to pause the video and give these a try and test your memory, then now might be a good time to do that. So pause the video. When you come back, we will have a look at them. All right, thinking BEDMAS. BEDMAS is really the most common in my mind, but I'm willing to listen to other short forms. BEDMAS tells us we should do the brackets first, right? So we'll say this is equivalent to 15. I'm not doing anything with that yet. Divided by, let's do the brackets. 3 plus 2 is 5. And now we can, so we've carried that one out. There aren't any exponents. We should next do any division or multiplication. And there's only division, so that results in 3. All right. Here we have no parentheses or no brackets, so that we don't need that part. We don't have any exponents, we don't need that part. So next is division or multiplication, whichever comes first. So we will go here and do 15 divided by 3. Well, that's 5, and we're not doing the plus 2 yet. And now we can do any addition or subtraction. So then we have an addition. So as you can see, this one with the brackets and this one without the brackets, they look very similar, but they yield different results. We must be careful with things like that. Okay, so here are 2 more to practice. If you want to pause the video again and practice those, follow the correct order of operations. Also remembering that in D, I've included not brackets, but absolute value symbols. All right, so we're back. We're going to look at BEDMAS. Let me just spread that out a little bit better. BEDMAS. Okay. So there aren't any brackets. There aren't any exponents. Is there division or multiplication? Yes, we have a multiplication right here. So let's do that one. 3 times 2 is 6. And now we have addition, subtraction. 14 subtract 6. All right. Now, when I introduced absolute value symbols, I said that they are not brackets, but we should evaluate what is inside them before we apply the absolute value to them. So let's see. The absolute value of, what is 4 subtract 6? The temperature is 4 degrees. It goes down 6. We're at -2. Subtract the absolute value of 2 subtract 8 -6. Okay. Now, before we do this subtraction, we should find out what these values actually represent. And the absolute value of -2 is 2. Subtract the absolute value of -6, which is 6. Now we will do 2 subtract 6, which is equal to -4. Okay, so evaluating expressions with signed values, as I showed in one of the examples above, it is generally more convenient to change the operations and the numbers so that the result is found by addition and subtraction of positive numbers. That's the key there, okay? So this is if you find it helpful. You don't have to do this. What this means is, instead of working with an operation on a negative number, I want to find out what would happen if this was a positive number. So if I change the sign of the number, then I must also change the operation to the opposite. So this becomes 6 subtract +2. So now I am performing an operation with a positive number, and 6 subtract 2 is 4. The same can be done in the second example. Instead of working with a negative number, like this, subtracting and negative, we can change the sign of each. This becomes 9 plus +5. And 9 plus 5 is 14. So if you find it helpful to change the sign of the number and change the operation to the opposite, then that will work. But remember, you must change both. Lastly, in this section, we'll have a quick look at operations with 0. So this tells us that adding 0 to any real number doesn't change the result, and we still have the same number. So numerically, it should make sense if I were to say that 8 plus 0 is equal to 8. That's what we're looking at. And the same goes with subtraction. 10 subtract 0 equals 10. No change, right? Just wanted to reinforce this idea. With multiplication, multiplying any real number by 0 results in 0. So we would just take a look at an example. 5 times 0 is 0. For division, division is not commutative, so it does matter what order we do it in. If it's 0 divided by a number, then the result is 0, as long as that number is not 0 itself. So lots of times we like to think about division. If I have 0 pizzas, okay, 0 pizzas, and I'm going to divide those 0 pizzas amongst a class of 40. How much pizza does everyone get? 0, right? The other way around, a divided by 0, anything divided by 0 is considered to be an undefined value. No number exists for this. Now, if both are 0, 0 divided by 0, this is called indeterminate. And that's because depending on the situation, there are various possibilities for what the result could be or how this is used. So for the most part, you will see we need to keep these two in mind. This one, less likely that you will run into that situation until you're into something like calculus, if you ever are. All right, that's the end of this video. Do some of the practice, and thanks for watching.